Okay, we're just going to be continuing on with lesson 5.4, which involves factoring. We left off with example 3, jumping into example 4. You can see I've just changed the directions ever so slightly to a solve. Rather than just factor, we're going to solve. Once again, I've brought this up. You're going to see it's going to be an ongoing, continuing, very important first step. Look at your expression here on the left. Ask yourself, is there a common factor other than 1 that I could divide out from all three terms? I have a 3x squared, an 8x, and a 5. 3 goes into the 3, but of course 3 does not divide into 8 or 5. As soon as you see that that's the case, you know that only a 1 would divide evenly into all three coefficients. So there's nothing in common. There's no greatest common factor other than 1. So instead, we're going to get started here. We know that we're going to have a 3x and just an x, because 3x squared, the only way I can multiply to that is to have a 3x and a 1x. But I am going to have to multiply to a 5. That's your constant term. In the middle term with an 8, we're going to have two numbers add up to 8. Now, multiplying to 5, there aren't a lot of ways that can happen. Just a 1 and a 5. Now, of course, you might wonder if I should put a 1 here and a 5 over here. Real quickly, you can see with the nose and the mouth, 1x and a 15x is not going to add up to an 8. So instead, let's just do a little bit of switching around here. Put our 5 in that first place, a 1 over here. Then we'd have a 5x and a 3x. That, in fact, will be able to add up to an 8x. Of course, we need to multiply to a positive 5, so we're going to have a plus 5 and a plus 1. Now, going back to what we had learned in the previous lesson on 5.3, we learned that when we were solving these equations, we'd use the zero product property, or the zero factor theorem, as some authors call it. The only way that this equation can be true is if one or both of the factors were to equal 0. So 3x plus 5 would equal 0, minus a 5 from both sides. We'll have 3x is equal to negative 5. Divide both sides by a 3, you'll get negative 5/3. Likewise over here, minus a 1 from both sides, you'll have x equals negative 1. So we do in fact have two solutions, and we're done. Okay, going on to the next page. We're not solving here, we're just going to factor. But as I had brought up before, a critical first step that you always have to look at is there a greatest common factor? Is there a number that divides into a 6, a 27, and a 15? And what is that greatest factor, the biggest common factor that we could divide out? Well, looking at 6, we know that 2 divides into 6, as does a 3, and so does a 6. But looking at your 6, 27, and 15, you know that 27 and 15 are not even. But a 3 divides into all of these factors. Obviously, a 6 does not divide into 27. But look what we're going to do. We're going to divide out, or factor out, a 3. This is a required first step. I was bringing this up earlier, and it's always the first question that you must ask yourself. Is there a greatest common factor that you can divide out? You must divide that out if that's the case. Well, look at what's about to happen. At this point, you can see that you do have a quadratic still inside. You have a coefficient of a 2. So we're going to have a 2x and a 1x over here. It's as if we're just going to factor out this remaining trinomial. It's like a brand new problem right in here with the 2x squared plus 9x minus 5. So we'll break this down. And we're going to be looking for two numbers that will multiply. We'll look at your constant, multiply to -5, and there aren't too many ways that can happen. We're also going to look for our numbers to add as we draw on our nose and our mouth to a 9. Now, multiplying to a 5, like I said, only a 1 and a 5 are really going to do that for you. So you can think about either putting in a 5 and a 1 or a 1 and a 5. I think it would just take a moment. If you tried the 5 first, look at your nose and your mouth. 5x and a 2x. There's no way that that could ever add up to a 9. So very quickly, we're just going to put our 5 and 1 and switch them. Put the 1 in the first parenthesis. Why is that so important? Because now we're going to see 1x, and then 2x times 5 is a 10x. Can a 1x and a 10x add or subtract to a 9? Yes, if we have the 1 being negative, the 10 being a positive. Remember that if one of your terms is negative, the larger term controls the final sign. We need to add up to a 9. That means that it's a positive sum in the end. The bigger number must be a positive. So we're going to have our 1 being negative. We'll put a minus over here. We'll put the plus over with the 5. 2x times 5 is a 10. Negative 1 times x is negative 1x. That adds up to a 9x. Don't forget, you must check if you really are multiplying to -5, and indeed you are. -1 times 5, checking this last multiplication, works out to -5. And that's it. We're actually done here. Let's move on to number 6. Problem number 6, again, the same ongoing issue. The question is, before you even begin to try to break down the factoring the way we just finished working out, you have to first say, is there a common factor I can divide out? Well, with a 4, with our leading coefficient, you realize that a 2 divides into 4, and so does a 4 itself. But the middle term of -6, obviously a 4 wouldn't divide into -6, but a 2 would. And a 2 would also divide into the 2 right here. So a required first step is to factor out that 2. Guys, this is so important because if you forget to do this, your problem just won't factor correctly. You have to check for that greatest common factor. Divide out that number from all 3 terms, and then it's like you have a brand new problem. And thank goodness we have much simpler numbers then as a result. So it's always a good thing when you can see that you can take out that greatest common factor. With a 2w squared, we of course will try a 2w and a 1w there. But let's see here. We're going to multiply to a 1. And we're going to have to add to a 3. Now, there aren't too many ways you can multiply to a 1. You obviously are just going to have a 1 times a 1. So let's put a 1 in for both spaces. Draw on that nose and the mouth, and you'll have a 1w and a 2w. Can we get these to add up to a -3? Well, the only way is if both of these terms would be a negative. And in fact, that's exactly what we want to have happen. Then we would add up to a -3w, but so importantly, you have to check that you are multiplying to a +1. -1 times -1 is going to multiply to a +1. We are good to go. All right, one last problem. Take a look at number 7. Right here, there is no common factor other than a 1. 5 being the leading term here, obviously only a 5 and a 1 divide in. And 19, you can't have 5 going into 19. So what you do very quickly is just come up with a 5x and an x. We need to multiply to a 4, and we're also going to have to add to a 19. Now, with the 4, of course, kids might wonder about this. You could have 2 and 2, or you could have 4 and 1. Checking with a 2 and a 2 isn't wrong, I think you just quickly see that it's not going to work. Drawing in the nose and the mouth, you'd have a 2x and a 10x. There's no way that this can add or subtract to a 19. So instead, let's try the 1 and the 4. And in fact, what will be more helpful is to put the 4 in the second parenthesis, because 5x times 4 is 20x, and then we'd have a 1x. But you might notice we're in trouble. We actually want to multiply to a negative 4y squared, and we want to add to a 19xy. We're going to need to put y's for these last terms. And then we'll have a 20xy and a 1xy. These can add up to a 19 if the 20 is positive and if the 1 is a negative. And then, sure enough, you add to a 19xy. Double check your multiplication. Negative 1y times 4y is a negative 4y squared. And then we're good to go. All right. Well, that wraps up this lesson. Keep working on this. This takes a lot of practice, but you will get the hang of it.